Welcome back. In this video, we will discuss the concept of three-dimensional database used in ETAP. The concept of three-dimensional database is built on the fact that when you create a one-line diagram model, ETAP creates three major components called presentations, configurations, and revisions. The way we view our one-line diagram in ETAP is called presentation. Presentations and views are synonymous in ETAP. New presentations would allow us to customize the way we view our one-line diagram. Revisions, on the other hand, would allow us to modify engineering data associated with the elements in our one-line diagram. If you recall, in our previous video, we entered some basic engineering data using the equipment editor. This initial data got loaded into the ETAP project base revision. ETAP organizes engineering data under revisions. Finally, we configure the status of this element to show the normal mode of operation. We can change their configuration to represent other mode of operation, such as emergency. Now we have some basic understanding of what are these major components. Let's build some presentations together. To create new presentations, you would have to work with the three-dimensional database toolbar. The three-dimensional database toolbar is here. To create a new presentation, we'll click on this one here and we will name our new presentation OLV2. Now we can see that we have two one-line views. The first one is named OLV1, the second one is named OLV2. To display both of them on the screen, you can go to Window and Tile Vertical. Now you have both OLVs listed. OLV1 is on the right and OLV2 is on the left. And to center this one-line diagram, just click anywhere and press this zoom to fit. Similarly, you can do that on OLV1. Okay, we have two identical one-line views. The reason why these views are identical is that you can create new views only while you are using the base revision. And since editing your one-line diagram requires you to be in edit mode using the base revision, adding or deleting any elements will be reflected into all views. For example, if we add an element and OLV1, it would be reflected in OLV2. Let's add a power transformer on OLV1. And as you can see, it gets immediately reflected on OLV2. If you delete connections in OLV2, it also would be deleted on OLV1. And the benefits of doing that is to maintain consistency among all your views. The views would allow us to customize the way we display the one-line diagram or customize the results on the one-line diagram. And to customize the one-line diagram, let's work with OLV2 by selecting all elements in OLV2 and then right-click and then change all the symbols from ANSI to IEC. Now you can see we can change how the one-line diagram gets displayed on OLV2. Similarly, you can change the size of this component or move components around, and that will not be reflected on the other one-line views. But I think the most important feature of having these different views is the ability to display different results on different views and also run different analysis on each view. For example, we can run load flow using OLV2 and run short circuit on OLV1. So to do so, we can go to OLV2, activate that, run the load flow, and this shows us the results of load flow study. On the other hand, I can activate OLV1 and run a short circuit, faulting bus 2, and then see what the results here. So as you can see, you can run different analyses and show different results. Okay. At this point, I want to show you how to create a one-line view in an alternative way. You can do so by going to the System Manager, and in the System Manager, we will be working with the multi-dimensional database, and we are working with the presentations right now. But in presentations, you can see that your one-line diagram contains two views. In here, you can right-click on that and then create a new presentation, and let's name that OLV3, and this would be created under the folder here. Now we have three views. This right now shows two, but we can show all of them by going to Window and Tile Vertical. Now you see that you have OLV1, OLV2, and OLV3. Now let's say you want to delete a presentation. In the System Manager, again, you can go to Multidimensional Database And then let's go with OLV3, right click on it and then purge that view from here. Okay, now we have only 2 views in our project. Let's say I want to rename the views. Click anywhere on the OLV and then you will see OLV name coming here. You can change the name from OLV2 to anything you like. Okay, so with that can summarize what we need to know for presentation. Let's talk about configuration. So initially, when you create a new project, the configuration status for the network is set to normal, which was the default condition. And basically, we configured the operating status of each element associated with this one-line diagram to show the normal plant alignment or the normal mode of operation of my network. For example, sources such as power grid can be configured to be operating in a swing, voltage control, megavar control, power factor control, and we selected a swing for the normal configuration. Similarly, you can configure protective devices such that they can be set to be in a closed or open position. As you can see here, all these circuit breakers were set to be in a closed position except circuit breaker 7. Loads associated with this project were set to be operating in a continuous mode of operation. Basically, loads can be operating in a continuous, intermittent, or even a spare, and we selected continuous for the normal configuration. So in a summary, you can see that during normal configuration, the network was configured such that the utility comes in, feeds bus 1, and bus 1 feed transformer T1, which feeds the associated bus, that is bus 3, and its associated loads. Similarly, bus 1 feeds transformer T2, and transformer T2 feeds its associated bus, that is bus 2. And there is no cross tie between bus 2 and bus 3. That is, the circuit breaker 7 is set to be in an open position, as you can see here. Another aspect that we need to cover before we launch the configuration manager: when we place elements on the one-line diagram, we place this element with a predefined default configuration status. For example, if I grab a power grid and place that on my one-line view here, I double click on it and the equipment editor shows me that the equipment is set in a swing mode of operation. Similarly, if I grab high voltage circuit breaker and place that on my one-line view, and you can see here that the default for my circuit breaker already was closed. So I just wanted to point out that when you place elements on the one-line diagram, they come in with a predefined or a default configuration status that you want to bear in mind when you connect your network. So such that if you want to change that status to something else, you may need to go to your equipment editor and check. Okay, now let's work with configuration manager to create a new configuration to represent the case where we have to take transformer T1 out of service due to maintenance. And if we want to take transformer T1 out of service, we probably need to isolate it first, and that means we have to take circuit breaker 1 and circuit breaker 2 to the open position. If we do so, we would lose power to bus 3 because transformer T1 feeds bus 3. So in this scenario, we would have to feed bus 3 via bus 2. And we are going to do so by closing the cross-tie circuit breaker 7 to the closed position. So let's do that together. We'll come here, we'll launch the configuration manager, and then you can see here we have only the normal status. And then we can create a new configuration by starting from a new point, or we can copy an existing configuration and then manipulate its components. So let's start with a new. When you start with a new configuration, the elements will come with the default configuration as we stated earlier. So I can press new, we'll give it a name, T1 underscore out of service. The point to take here is that when you start from new, the elements will have the predefined or a default configuration assigned to them. For example, a circuit breaker will be assigned the closed position. Power grid sources will be in a swing mode of operation. Motor operated valves will be in an open position, and so forth. Okay, and in here you can see this here, associate the device selection to be shown on the right hand side. And in our case here, we are trying to configure circuit breaker 1 and 2 to be in an open position. So if you click on this box here, it will highlight the element in red on your one line view. If you click on the status here, you can configure that from close to open. Similarly, we need to do the same thing for circuit breaker 2. You can choose from the drop list to change the status to open. We need the cross tie to be closed such that bus 2 feeds bus 3. Okay, so in our case here, we have two configurations, one called normal and the one we created called T1 out of service. And this here, the device selection shows the AC elements. So your project contains only AC elements for our case here. And these elements here are all the elements associated with our one line diagram. And these are the statuses for each configuration. And one of the display options here is checked currently is called the normal status. And under the normal status, basically for elements on your one line diagram, you can display the normal default configuration. So for example, right now all your circuit breakers are shown with their normal status, that is the close, and also it shows the open. And if I uncheck this one here, it will not show me the normal status for your device. So for example, we stated that the normal default configuration for breakers is closed position, and therefore if I uncheck this one here, it will not show me that normal because it's unchecked, and it is going to show me the alternate or the off normal status, as you can see here. Okay, if I check it, it will show me both the normal, which is the close for circuit breakers, and the off normal or the alternate, which is the open. Finally, you have difference, and you can check this one here. So basically, if you check that difference here, it will show you devices that have differences between their configurations. And as you can see here, circuit breaker 1 is closed under normal, but it's different under T1 out of service. And this one can give you a quick comparison between configurations. All right. The other items here are quite self-explanatory, and it's not that hard to figure out. So let's move on with revisions. Now it would be a good point to link what we've learned before when we created this presentation. In fact, you can attach any one-line diagram presentation to any configuration. So let's do that. Let's show both presentations and then attach one to normal and the other one to T1 out of service. Let's go to the multidimensional database, and in here we have configuration, and I see that we have two. And for the presentation, I can see here my one-line diagram contains two presentations. So this is OLV1 and this is OLV2. Let's show both of them, where OLV1 is assigned to the configuration normal, and this is the OLV2, and we can assign that to T1 out of service. All right. Since now we can attach any configuration to any presentation, we also can independently run load flow on each presentation. For example, I can use OLV, which is aligned to normal, go to load flow, run that. Similarly, I can take OLV2, align that to T1 out of service, and run the load flow studies. Now I can gain insights and provide recommendations based on the results coming here from the load flow study. And to just give you an example, the current going through circuit breaker 6 during normal was just 21 amp. But in the case where we have to take transformer T1 out of service, look at the current now going through circuit breaker 6. It's a 188 amp. That's because all the loads on bus 3 are now fed from bus 2 via this cross tie. So with the ability to align configurations to presentations, we can now display different results for different scenarios where we can provide recommendations on this type of alignments. Now let's look at the option on how to work with the system manager to launch the configuration manager. Under the system manager, let's go to the multidimensional database, and from here you can navigate down to configurations, and under configurations you have statuses, and as you can see we have the normal and the T1 out of service. You can right click on a status and you can launch the configuration manager right away, and then you can copy a configuration you created and then manipulate its elements. For example, I can click here on T1 out of service and then duplicate. Then you can create or copy from an existing configuration such as normal or T1 out of service, or you can create a new configuration based on default setting. And if you click on this, you give it a name, and it tells you that the configuration status for your element would be listed as such. Okay, in the next portion we'll talk about revisions. Let's go there. Now imagine yourself you have a need to examine the network for future modification or a suitable replacement for one of your transformers such as this T1 here. Now you can change the engineering data to reflect the future transformer parameters in the revision data and then compare the results to the base revision. Now let's examine the impact of changing some of the engineering parameters associated with this transformer, and we are going to examine the impact of changing the impedance from 6.5% to something like 7%. And then we can compare results to the base revision. And to do so, we are going to work with the three-dimensional database toolbar. Specifically, we are going to launch the data manager. We can do so by creating a new revision. Click on create. Since this is the base revision, if you have other revisions, we can copy from other revisions, but for now we don't. So let's call that T1 at 7%. Now you can see we created a new revision. The new revision here is called T1 at 7%. Okay, and right away we can see there is no difference between the impedances related to the transformer T1 in our case here. To make the changes, we gotta close this, and now let's work with the T1 at 7% revision, and from here we can change the impedance of my transformer from 6.5% to 7% for both a positive sequence impedance and a zero sequence impedance. Press OK. Now you can see that T1 at 7%, that's my revision, and then we can see that at base it's at 6.5%. We can go back to the data manager. You can see now the difference between the base and T1 is listed here in red. You can also look at elements, and you can look at all elements in totality instead of just properties of each element. You can look at all your elements and quickly spot what has changed from base to other revisions. And as you can see here, this one is reflected. And now we have the ability to look and investigate the impact of changing this transformer to another transformer with a 7% impedance. We can run load flow based on base revision and obtain results. Okay, now we can change that from base revision to revision 1, where it has the T1 at 7%, and run the load flow, and it appears to me that there is no significant difference or a difference at all in terms of the load flow analysis. But maybe there is a difference in the short circuit, right? And then we can run that at base and look at the short circuit analysis as a result of changing this transformer. And you can see here the contribution at base is about 10.05 kilo amp, and if we run that at 7% impedance, okay, that changed from 10.05 to something like 9.37. So there is a change here. And this is the way you can investigate the impact of the changes on your system as a result of changing some of the impedances like this. So the concept of three-dimensional database allows us to modify the one-line diagram to address future expansion, investigate the impact of new configuration such as emergency alignment. We also can look into replacing an equipment with another that has different plate name rating, or provide recommendation based on changing some of the engineering parameters. And we can do all of that while we're just using one database. This great feature can save us time, where we can just look at and analyze results instead of creating copies to address these different changes. With that, I want to thank you for watching Power Source, and good luck.